So did you get your lunch, everyone? Welcome back. I'm a big fan of functional programming. I think that's very good because you get a quite concise code doing that. And so I'm very happy to see that coming more and more in Java. But how to avoid the pitfalls in functional programming in Java? That's the subject of next talk. Welcome, Brian.
Hi. Thank you. Thank you. Such a big audience. Awesome. Yes, the slides are on. Awesome. I want to start with a little story. I have a little cousin. He's about 2 years old. And I gave him a present last week. It was a new toy. And he loved it. And he wanted to do everything with it. He wanted to go to bed with it. He wanted to go to nursery with it. He wants to play with it. Wants to go to the toilet with it. Wants to go in bed with it. Everything. And that's typical for little children. But if you look at us as developers, most developers, I would say, perhaps not you, but you know a coworker, perhaps who does. If we have this shiny, new kind of technology, we want to implement it everywhere. And that doesn't necessarily mean that people actually read documentation. Probably you do. I do. But I bet you have a coworker who doesn't do it. And the code that is implemented will be working, but it's probably not the way it should work or it was intended to be. If you see this motorcyclist over here, are there any people here in the room who drive a motorcycle? A few. I mean, you can drive a motorcycle like this. It gets you from A to B, but I'm still wondering how this guy shifts gears, because normally you do that by foot. So by doing something and saying it works doesn't mean it actually is the way it should be. And it's like that saying, right? If you have a hammer, everything looks like a nail. And I mean, we have to work with people from other specialties, people that are into the features and are more business-wise. And you probably can say to them, well, it works like, and if it looks stupid, but it works, come on, it's still stupid. And perhaps you can convince your business owner, like, yeah, can't trust me. It works. But is it the right way? Probably not always. So we're going to look into functional programming, and we're going to get some of the mistakes that I've seen over the last couple of years that I worked as an engineer, and we're going to light them out and see how these things can be better. Probably some of these things will be quite obvious, but the thing is that the obvious things go so much of the time go wrong. But first of all, who am I? I'm Brian. Since 5 days, I'm a developer advocate for Snyk, and Snyk is a security company. And what we do is simply, we have a couple of tools which you can scan your, for instance, your open source software on GitHub. You can connect it to our platform, and they will scan your vulnerabilities. They will scan your dependencies, because you might write awesome code, but you don't know what your dependencies do, right? But that's not why we're here. So I'm a developer advocate for Snyk. I'm working for the Utrecht Jug, which is one of the biggest jugs in the Netherlands, and they say I'm an Oracle groundbreaker. Well, let's go to the first mistake, or the first pain point. That is doing too much in a single lambda. Well, okay, that sounds obvious. But what is a lambda? Well, if you look it up on Wikipedia, you get something like this. A lambda expression is a functional definition, and it's not bound to an identifier. I mean, it can be used to pass it as an argument to a method or to a function, or it can be the result of a function. So basically, it's a first-class citizen, but without an identifier. But what does that mean in Java? Well, we can treat it kind of like anonymous inner functions. It satisfies the functional interface, they only exist in runtime, and you have two ways to write them. You see on the lower line that we have the input, the function arrow, and an output, and you've got the block notation, which has an input, a function arrow, and a body. Let's go to the first example. In red, you will see a very naive higher order function. It takes a beer and a function. as an argument, and it simply applies that function and does a side effect. Nothing much, but just for the sake of argument. Over here, we apply a lambda on it, and, well, this function is quite readable. We have a beer, we want the name, we want the alcohol percentage, and we want to print it out, right? Lambdas are meant to describe these functions in line as an argument. Can you imagine that if you want to do this like this, and you want to straight away do this in line, and your function will look like this? I mean, I've seen lambdas with if, else, nested, where, switch, whatever, and try catches in it, and people think, well, that's the way it's supposed to work. And afterwards, you talk to these people and say, I hate lambdas. Yeah, sure, if you write them like this, I know, I quite understand why you hate them. And you can argue about it. Why do we have multi-line lambdas? I would say if there's more than one thing in a single lambda, you probably have to split up, you have to separate your concerns. But okay, say you want to do more in a single lambda. We have this thing in Java, which has been here since, I guess, 95 or something, which is called a method. You simply abstract it and write it into a method and give it a good name. I know, we're all good in naming, right? And if you give it a good, correct name, you can use the annotation as you see on the lower line to do it in your higher order function or in your stream API, and that makes the code more readable. The problem with functional programming is, or the point of functional programming is that we want to have concise code, we want to have readable code. And if you do these large kind of block lambdas in line to a function, it's probably not readable. Let's go to the second one. Returning a stream. This one is always a debate. But you have to know something about a stream. I mean, first of all, it's not a data structure. And second most important thing is, it's not a data structure. But okay, you tell me what it's not. What is it? Well, it's a bit fuzzy. It's a flow of data that's derived from something like a collection or something. It's lazy by nature, and it is meant as an intermediate result. With these streams, you can create a pipeline, and you can transform data but not mutate data, so they say. So just to dive in a bit, you probably all know this, but if you have a stream like this, you have two kinds of functions, intermediate functions and terminal functions. The intermediate functions like filter, limit, distinct, whatever, return you a stream, and they are meant to build up your pipeline. But they do not do anything, because lazy. The terminal function reduces it to something that is actually useful. Reduce function or collect it into a list, and by using that, you finally kick off that stream, and you will have working code. But back to that stream point. One thing of a stream is you only can use a stream once. So if you want to bind it to an identifier, as I do on the second line over here, it's pretty crazy. Why should I? Because if you bind something to an identifier, you probably will use it twice. And as of here, the first for each statement works, but the second one doesn't work because it is not a data structure, and you will get an illegal state exception. Knowing this, you should be careful by returning a stream, because if somebody calls your function and it returns a stream, how does he know for sure that the stream is not already consumed? He simply doesn't, because we cannot check. We just have to put it in production, YOLO, and see if it works. So returning a stream can be useful. I mean, if you have your own private intermediate functions and you want to build up your pipeline, it's perfectly fine to introduce or to deliver that stream back. If that stream is created every time, once again, on the way, I mean, if the stream is created, if there's a new stream created every time, like list.stream, it's perfectly fine. If you have a very large amount of data, say millions of data, you probably do not want it in a collection, because I think you will run out of memory. And because of the laziness of a stream, it's kind of worth to use a stream. But by default, I would say you will prevent a lot of problems, and also a lot of problems with less senior developers, that you make it by default returning a collection. Well, these were pretty obvious, right? I told you about that stream. Just over here you see a visual about it. Yes, I draw this. No, I cannot draw. You have this pipeline. Say the first pipe is a filter, the next one is a map, and you call it. And it doesn't do anything. But if you reduce it to something that's necessary, that gives it purpose, like collecting it to a list or to a set or reducing it, and you call it, then your stream will work for you. Okay, it sounds legitimate, but look at this piece of code. What's wrong with it? Quite obvious, right? Because the topic was not consuming a stream. Duh. It isn't consumed. It probably, if you look at it from a first glance, you will say, okay, if it's bigger than 7, it will throw a runtime exception. Yeah, fine. So that means that at the second bear, which is 9%, it probably puts a runtime exception. But the problem is that peak is an intermediate function. Peak returns you a stream, so it doesn't do anything. Because I ran it yesterday evening, and I'm still waiting. But if you consume the stream with, for instance, a for each, and that one kicks off the stream and makes it actually useful, then you will end up with that side effect. And that's the problem with it. Peak is something that can handle a side effect inside the stream API. And you can do this, but please don't. I mean, it is meant to be useful, for instance, for debugging. If you want to look inside your stream, because your stream is a pipeline, and you want the intermediate result to be printed out, for instance, then you should use peak. But do not put any other logic in it. Like, yeah, well, we can transform something, and we can do something, and then at the end, it will become horrible. So don't use peak unless you do just outlines or logs. Then the biggest question, or the biggest point in functional programming: mutable objects. And this is also always a discussion, because people will say, yeah, mutable object or immutability or whatever. It will have the problem that it will create more objects in my heap, and well, the garbage collector needs to kick in. You probably should talk to Oleg. He's the one from GraalVM that will solve all your problems. But if you look at functional programming in general, just the concept of functional programming, it's based on a few things. And yeah, I copied this from Wikipedia, because if it's on Wikipedia, it's true. And you see there are a few things in this definition that are quite important. And you probably noticed they're in red. Functional programming consists of functions, tries to avoid changing state, and mutable data. It's a declarative programming paradigm, and it's done with expressions instead of declarations. But most of us, we do work with mutable data, right? I mean, but think about it. If I ask you a question, for instance, what's your favorite color? You would probably say it's blue or green. And I ask you again, would that change the way you think? Probably not. Probably you will say blue again. But if you work with mutable data, you have no clue that what comes in and what comes out has any relation to each other, because you can change state. Well, if you have multi-threaded systems, the state can change intermediately. And actually, if I have to quote one of my favorite scientists, insanity is doing the same thing over and over again, expecting different results. Well, I work with mutable data. So I'm quite insane. But it is, right? If you work with immutable data, it's very handy, it's very much more debatable what the code will do. If something goes in, and the function just asks a question or just does something and something comes out, and it's every time the same, then it's quite predictable what the code will do. Because in small examples, as I will show you in a while, these things are quite obvious, but most of you probably work on large enterprise systems, and we have to debug. And we have to jump through types of code. And then if state changes, you have to keep your mental mind map in your head to, okay, what state is this object in, and does that work for me, and how does it come that I have this edge case situation? By making sure that you have immutable data, you probably have less of these worries. I mean, asking a question should not change the answer, nor should asking it twice. Just a second. So, immutable objects give you less moving parts. It's easier to reason about that code, because that's always the problem. We have to reason about it. Probably you do not work alone, you work with coworkers, I hope. And you do not have to keep a mental mind map if the state of an object is always the same. And they say that in a stream, you cannot mutate, right? Well, let me get to some code. It's more fun. Let's go to this. Can you all see it? I hope so. You probably can. Who cannot read it? No hands? Perfect. So, over here, I have my beer library with 2 beers. It's not much of a library, but still. Say I want to, for instance, I want to do something like this. I want to map over it, and I want to say, well, I have this beer. Oh, the problem is, does it have a setter? No, it doesn't. Now it does. So I want to set the name, and I want to use the original name as well. So I say, all right, that doesn't work, right? But they say because you cannot mutate inside the stream. But if you look at the error it throws, it said, no instance of type variable R exists so that the void confirms to R. That means the void is the problem. But wait, I can change this. Say I have this setter. Normally it's like this, you know? Oh, wow. Typing is not my strongest suit. This would be your normal code. But if I simply change it to the one I see above here, the with name, oh, this is not good. Just a second. I had to prepare better. Well, again. Normally, you have a setter like this. Right? But if I just changed it from void to beer, and I ta-da, and I do it now, it works, right? So let's see what it does. By running this at this moment, you will see that both the original and the new list, I was able to mutate the objects. So they say you cannot mutate within a stream. You can, but you shouldn't. Because I just gave you a whole speech of mutable and immutable data. So what should you do? Well, it should be quite easy. Instead of making a setter, just return a new one. With the new name, right? And the original, in this case, alcohol percentage. By doing this, and going back to the code, of course I have to rename it, because I now changed the name of it. By running this code, you will see that my new list contains the new names, and my old list, my original list, contains the original ones, which is quite more obvious and quite better to reason at. So, again, don't mutate data. Well, I showed you this. You should not mutate. You should return a new copy. For each, that's a nice one, because people make mistakes about what functional programming is. They say, well, functional programming is declarative programming, right? Yes, but not all declarative programming is functional. There is a slight difference between it. For each terminal function on a stream, of course, it's also a function on a list or a set or whatever, but it's a function. It's a terminal function on a stream. It takes consumer, and the fun part is it can apply a side effect, or you can mutate. It's actually nothing more than syntactic sugar for a for loop. So, say for instance, I have this code, a list of names, and I want to map it to uppercase, and I want to print it all out. This is quite a very simple and most used example. But what you can do as well, of course, is mutate the data. Should you? And what I saw in it was actually a few weeks ago, I was working on, it was of course not a beer example, but an example for, in this case, a real-life app for a banking system. It did a batch job. And every time what it did was, I have my object, in this case, the beer, and it wanted to enrich that object with data from other sources. So source from a database A and a source from database B, want to enrich it to one object, and then store it in another database so it can be used for a certain app. And I saw this kind of code where multiple lines of for each were used. And I was talking to the guy like, why did you do that? He said, well, it's quite readable, right? Because that's the main part of functional programming or declarative programming, that you say what you want to achieve instead of how to achieve it. Well, I have to say, yeah, that's actually true. But do you got any clue of what you're doing? I mean, for each terminal function, that means that your whole stream, in this case, will be evaluated from top to bottom. And then you do that again. And then you do that again. If I would show you a for loop example and say I do this for loop 15 times, you will say you're freaking insane. Just do that in a single for loop. By doing this, you probably think, well, functional programming, lazy evaluation. If you have no clue what it actually means, and you do it like this, it's quite readable. And for somebody who's not into it, says, well, it works. We've got tests. Perfect. But by combining this and creating, in this case, new objects, we increase the speed of that batch job from 14 hours to 4. It's quite an impression. Next one, order of operations. There is a misunderstanding that because streams are lazy evaluated, the order of operation doesn't always matter. So I've got a question for you. Every beer has a brewer. Every brewer is from a country. So now I want the first three unique brewers' countries from my beer library as a comma-separated string. The question I ask you, is this code correct? Oh, I already clicked. Sorry. Nope, it's wrong. But it's quite obvious it's wrong, right? Because I'm talking about mistakes. The distinct and the limit are in the wrong place. If I move them down, I will actually distinct on the right part and limit it to 3. Well, we are all good programmers. We write unit tests, and we find this out before we go to production, right? Yeah. Well, finally one. Most of them's like, yeah, kinda. Okay, but this is quite, we can solve this by having good unit tests. And we all do good unit tests, so that won't be a problem. But let me go to this one. I have an iterator, and I call distinct on it, and I limit it because, yeah, well, probably infinite, so I want to limit it. And then I want to print it out. So, okay, I didn't test it. I put it in my cloud production system, and let's see what it does. It gives me a 0, it gives me a 1, but it's still busy. And if you simply look over here, it's still occupying one of my CPUs, right? But that's crazy. I limit it, right? So let me turn this one off. What's the problem over here? If you look at this iterator, it gives you the following numbers: 0, 1, 0, 1, 0, 1, etc. So the distinct in this part says to us, okay, 0, 1, 0 I already have, 1 I already have, and so forth, and so forth. Then you got the distinct. My first item is a 0, and you feel it. My second item is a 1. My third item is, and it's waiting. It's stuck. The problem over here is that the order of operations is wrong. Because if I simply would put the limit over here instead of here, and I will run it now, you will see that it terminates. If you do this on your production system and it's probably in the cloud, you will have a good job. I think your manager will be awfully great with you and paying the bills for ages because, well, we didn't test. But can you imagine what will happen if I do this? Let me run it. Now it doesn't do anything anymore. Or is it? Well, it does do something. It gets me warm in here. I mean, that's good. It's snowing outside. Well, let's quit that one. Because the problem is, let me quit that one first. Quit, please. Thank you. The problem is that, first of all, we use a parallel stream. Well, you probably know that if you use a parallel stream, it will get and will take the common fork joint thread pool. And what does parallel do? It forks and it joins. So at this part, at the parallel, it will fork and do things in parallel. And at the end, that means at the for each, it tries to join all the parallel threads together into one result and gives it back to you. But it's stuck over here because it cannot get to the third item. If I initially made it a limit 3 or a limit 2, then it would work, of course. So you have to be careful with these kind of things because we have a few problems in here. I showed you this, will run forever, sometimes will terminate. So, first of all, you have to look closely at the order of operations. The order of operations is important. It will be evaluated from top to bottom. And not because it's lazy, you can mix it up and mix it around because you will end up with a wrong result. But we can test that with unit tests, no problems. The second point that I wanted to make here is that do not use an infinite stream. You can use infinite stream because of the lazy nature of it, but why should you? I think in 99 out of 100 times, it's not necessary to use an infinite stream. It will only give you an extra layer of complications. By using a range or a range closed or an iterator with a predicate like the lower line as from Java 9 is implemented and further. You will have a strict bound iterator of a strict bound range in that stream that at least will terminate, and you will not end up with your system blowing up and getting just a very expensive heater. Optionals. Optionals is a weird one. I mean, they say it's the Java implementation of the maybe monad. Nobody's running because most of the people are scared of the monad word, but it's not that important. I mean, what it does, it tries to it tries to encapsulate a certain possibility, a certain behavior. In this case, the possibility that the value will be null. So in Java, we can consider it as a wrapper. And why do we have this? So we can give a message to our user that he has to unpack the optional first before using it. And to prevent null pointers in that case. All right? But this is possible. We live in an object-oriented world. And by assigning a null to an optional, we have the same problem all over again. So please, although you may think that an optional can be filled with something and be empty, it can also be null. But if we just discuss over here that we will never do this, we will never have this problem. So please avoid this. You have to unpack the optional. I get an optional from something, perfect, and I have to unpack it. So I get it. But the problem with this is I don't know if it's empty or not. So probably it would end up in a no such element exception. So what do you see if people use this? Like, okay, I'm not certain if it's filled or not. Let's check if it's filled. Which is quite obvious, which is quite a good way of thinking. And then you see this kind of code. I will guard it with an if statement. I get it. But the problem with this is I don't know if it's empty or not. Probably it would end up in a no such element exception. Oh. So what do you see if I know. I want to discuss with myself. That's good. I should do stand up with myself. Let's check if it's filled. Record myself first and then stand on the other side of the room like, no. Good way of thinking. You're talking crap, buddy. It's pretty weird to hear myself. Anyway, let's continue. The problem with this is you see that I want to guard it with an if statement. But can anybody tell me how this is better than just checking for null? I want to discuss with myself. And it's actually not the way you're supposed to do it. You can do this, of course. And it will perfectly work fine. But optionals have to be... Well, you can work with optionals in a different, more elegant way. You see that I want to because it has some functions like if present, you can give it a certain function. From Java 9 on, it has if present or else. You can use a map function, and all these functions will only apply the inner function on it if it's actually filled with something, which is quite easy, which is quite nice. We do not have these indentations and these strange if functions. So by using the if present and map functions that are applicable on a optional, you have a more elegant way of using an optional. Okay, that's all fun and stuff, but what else? I mean, if I want to do something else with an optional, then just getting it. If it's not there, I wanted to do something with it, right? So let's go to this optional example. We have a few options here. For instance, I have this optional that is, in this case, filled with a string. If it's there, it will run my runIfExist function. If it's not there, it will throw me a runtime exception. And that works perfectly fine. But, okay, say for instance, I do not have to run like this, but say I have another function, and I call it run if empty. And that doesn't give me a string, only only run if optional is if it's there, empty, and it returns me a string. If it's there, and I say, okay, if it's not there, I want to run the other function, which is quite reasonable. So I go over here, or else seems legit. Run if empty. Cool. IntelliJ says it should work, and I trust IntelliJ with my life. So my optional is filled, so eventually it will print out full here. Empty, and I say, okay, cool, let's run it. And it does. But what you see over here is that you have a side effect that people mistake that or else will not be evaluated if the optional is empty. And that's not true. You see that even though the optional is filled, the run if empty is called inside. It will not return that result, of course. But can you imagine if you do this with, say, for instance, your database? Just a small example. I'm looking for a user with a certain username or a certain ID. And if it's there, I want to return it. And if it's not there, I want to create that user. If I use it like this, then you probably have a problem with your DBA, or you end up with duplicate data. So, say I want to use something and I want to correct a different flow. I want to do a certain other flow when there is nothing in that optional. There is a slight difference because we have the or else, but we also have the or else get. And by using the or else get, it will take a supplier, a higher order function, and it will simply not evaluate it. No, it will only apply that supplier when it's needed. So it has that lazy kind of way of thinking. By doing this, I eventually end up with what I want. But so many people make this mistake the first time, the second time, and even if they didn't work with it for a while and I see the code back, that okay or else, because it's quite intuitive to use or else. And I think it's weird because I would say normally if you see an if else statement, we short circuit everything in Java. Except so it's counterintuitive that or else is evaluated anyway. And it should be another name in my opinion. But it has a slight difference, but you have to look at it and you have to write tests for it because or else you will end up with kind of a problem. And I think it's weird. All right, so what is it used for? If you look at the or else statement, it's weird. Yeah, we've got or else get, or else throw. I showed you all three of them evaluate anyway. Of course, or else will evaluate what's inside of it. Or else get will not, because it takes a supplier, and the supplier will be only applied when it's necessary. But it has a slight difference, but you have to look at it. But when you use the for else, you have to make sure that what's inside the or else does not contain any side effects. Actually, or else is only meant to be used to give back a default value and nothing more. So if I want to give a default string in this case, it's perfectly fine to use the or else. But if I want to do an alternative flow and I want to have side effects on it, or I want, because we do live in a world that needs side effects, you use the or else get. Please make that distinguishable. But when you use the for else, you have to make sure that okay, list of options does not contain any side effects. So I have this stream, and I want to give get the I have a life code string in this case used perfectly fine to your else. Say for instance I use another object which again is your name, alcohol percentage, and description. But the description is not always necessary. And my get description will return me an optional. If I run it like this, and I want to, okay, list of options. If get the, oh well, I have so I have this, I will get back optional whatever, and I just want the strings instead of the options. If we do this in Java 8 style of coding, then we could do things like, okay, first I filter if the optional is present, and then I simply map the optional. But the description, if I is not always necessary, run it like this, and not get on it, will return me an option. So if I run, I will only end up with the strings that are if we printed if they are there. But I would say, well, in optional we have this map and or else, and we have the flat map function in Java, right? If we do that again in a Java 8 kind of style, then we could use the flat map function. And say we have an optional, and yes, I'm good at name map. Optional. I could say optional.map, but the problem with this is it needs to return a string. If we printed if they are there, and if I run, I will only have to do something like else, and we have flat map function. This, so we return a stream of it, or else we return an empty stream and then print it. We have this map use the flat map function, and we have the flat map function. Again, this works. It looks quite smart, but I'm sure that there are some of your coworkers that say, "What? Why do you do this?" Luckily, if you upgrade from Java 8 to say Java 9, 10, or 11. From Java 9 on, there is a small enhancement on that optional, which you can simply say, return a stream of it, or else we return I want a stream of it. And if you look at the implementation, you will see it does it for you. Return a stream of it, returns the empty stream, empty stream. There are some of your coworkers that say, "What? Why do you do this?" And now again, my code is quite readable. So I urge you all, who's on Java 8 right now, who's working on Java 8, who wants to migrate to Java 11? Because I can imagine that you say Java 9, Java 10, whatever. I urge you to do so. And I know it's probably a hassle to do modularity. You don't have to use modularity, but that's a whole different story. There are some quite small code changes, some small syntax changes that can help you write even cleaner code. Take a look at it, because it can make your life quite more easy, because flat map, I think, is a very nifty function. And flat map in the old version of Java 8 used a for each statement, so that meant that actually my laziness in the flat map was not there anymore. But from Java 10, if I'm not mistaken, and on, that is fixed. All right, let's go to my final example. Just a second. Oh, wow. I hate this touch bar. All right. Who has any clue what this is? And don't say a rocket. Perfect. 100 points for you. It's the Ariane 5 project from the European Space Agency. It was launched the 4th of June in '96, if I'm not mistaken. And it had a little problem. Basically, it tried to convert a 64-bit floating point number into a 16-bit signed integer. The velocity from that point was converted from one system to another. And you know that if you do that, you have to make sure that it fits. Well, at the beginning, it worked out, but at the end, the velocity was that high, you had some sort of overflow. So, basic storyline is, exceptions are important to handle correctly. Say, for instance, I have my function is empty. And empty is a checked exception. If I want to use this in a lambda, or I want to assign it in this case to a function, and I want to use it like this, it's not possible, because it says you have to try catch it. Okay, fair enough. Let me go to code. So, again, I have my beer library, and I want to do this, and it says nope. So I follow IntelliJ, because I trust on them blindly. Cool. Oh well, now I have a problem. Well, perfect, fine, works. But we just agreed in the first mistake that we should not do block lambdas, right? Okay, fair enough. I will get this one back, and I will simply call this try something. Perfect, now I'm done. Well, if you need to use these kind of functions from libraries that do throw checked exceptions, and you need to do something else than just rewrap it into a runtime, you have to do some specific things because of when that exception occurs, this can be the way to go. This probably is the way to go. But, of course, who does do these things like, okay, wrap it in a runtime, ship it, because it will never happen? Who did that somewhere in his lifetime? I did. And simply because I think checked exceptions are crap. I hate checked exceptions, but that's a whole different story. We have to handle them, checked exceptions. But say, for instance, we work with checked exceptions. Perfect. Let's go back to the original point. If I want to do this, and I want to do this every single time I want to use a function that has a checked exception, I'd probably be smarter to write my own simple util. So say, for instance, I write my own simple functional interface. And I call it checkfunc, because again, I'm good at naming. And I simply have to insert or make sure that the apply function is there. This is actually the same implementation as a normal function, but now I can say throws exception. All right. By doing so and creating my own wrapper function, which returns me a normal function, and I call it wrap. Yeah, it's not important yet. And it takes a checked function as an argument. Cool. So now I just have to implement it. I have to return a function. And I simply apply that to this one. And then we have the same old story again, that it says, then it says, okay. You have to start with a try catch. Okay, normally I would make this different, but just for the sake of argument, if I just put it somewhere in my utility file that is down below, and we'll never see the light again, I now can use it like this, and I can use it everywhere, because statically import this utility function, and if my lambda needs to work with a function that has a checked exception, I can simply wrap it like this. My lambda is still quite readable, and I can continue because it compiles. But can anybody see what's the problem over here? The problem is that if you run this like this, this time it goes well. Let me run it again, and now you see that my exception kicked in, but you do not know when your exception kicks in. It can be at your first item, it can be at your second item, it can be at your 100th item. And you probably do not want to kill off your stream and kill off your pipeline when one of these items go wrong. And if you think in a more functional way, you probably could say that, okay, but why not simply treat these things that can go wrong as much as data as we do with the good results? To do so, I want to introduce a new kind of type. And probably if you work with Scala or something, you probably know this one, but it's not yet known in Java. It's called the either type. And the either type can either be a left or a right, because this is a very naive implementation. It's a private constructor with 2 static builders over here. So it can either be a left or a right, and it can be of any type. So it can be a string or an integer, or a string and a string, or an exception and an object. To do so, to use this, I can wrap this result into my either type, and by convenience, I will say the right is the right result, and the left one is the wrong result. This strategy is used in many functional languages to take care of this problem. And if you look at this function over here, I've made a lift function and actually do the same as we just did with that try catch and throw it as a runtime exception, but now I wrap it into my either right or an either left. By doing that, and I lift it over here, and running it again, then you will see that my first item in my list went wrong, my second item went right, and my third item went wrong. And now I'm back in control, because my whole pipeline, my whole stream pipeline can maybe consist of a million kind of ways. You can use it from top to bottom, and afterwards you can filter out the way the things you want. Do you only want the good results? Do you want the bad results to put in again and to retry it? It's now up to you instead of up to the compiler and crash at a runtime exception. The only problem is that some people would say, yeah, we've got the try in Scala that does the same. The only problem what we do now is we wrap the exception in the left part, and we omit the original value. But because the either type can handle every kind of situation, it's a generic type, I can also put my original value in it. And I made an example of it over here, lift with value, that in the left part does not only give you an exception, but I use a pair, which is part of Apache Commons, with the exception and the original value, or I simply apply the function on it. By doing so, and let me go to the yes, run. You will see that the first one goes wrong and has a pair with, in the first part, the exception, which can have some useful information in some parts, and the second part, the original value. So now I have all the information I need that I can traverse to my stream from top to bottom, and what goes wrong I can put in again because I conserve all the necessary information. That's why I think that the either type is stronger than just the try as in Scala, or the first example I showed you where we simply put the exception in the left part. Last thing, the try has the same things. It has a failure or a success. The failure can only have that exception, and the success can have a type. It's part of a library called Favre, formerly known as Java slang. If you do a lot of functional programming, you should look at it, because it can have some convenient kind of nifty functions that you can use. On the other hand, you see that implementing the either type over here, if you just want to use it for exception handling, it's not that hard to do it yourself. So, with the try, and that the Favre has a lot of these lift functions for you completely, but it has a lot of other things as well. Take a look at it, but if you want to, again, do exception handling only, you can easily implement it yourself. All code examples will be, of course, uploaded, and I will tweet about it. And that's it for now. I'm Brian. Again, I work for Sneak, and I want to thank you for your attention.
Thank you, Brian. We have questions on the side. And
yeah, if you have questions, please come up. Or do we have
next
time for questions?
next speaker in 6 minutes. So we should.
I'm a bit sorry.
Yeah,
I'm I'm a bit over time.
Thank you.
If you have questions, please come up. I will be around the conference for today and tomorrow, this evening. Come up, ask questions, and see you later. Thanks.